Hello, this is Mr. Thayer. Welcome to 7.3, the Pythagorean Theorem. A few things before we get started. Make sure you have your graphing calculator. Make sure you have this Pythagorean Theorem worksheet because we're going to do some problems off of there. And if you want some colored utensils, by all means, go ahead. And of course, your graphing notebooks. All right, let's get started here. This is the Pythagorean Theorem. Please copy down this image of this right triangle and label sides A, B, and C exactly as you see them right here. The Pythagorean theorem is a math theorem that helps us find the missing side of a right triangle if you know two sides already. The side that is opposite of this 90-degree angle is referred to as the hypotenuse. It's the longest side. The other two sides you see here are referred to as the legs of the right triangle. The hypotenuse must be in this location of the Pythagorean theorem. The other two legs of the triangle, a squared and b squared, are on the other side. Copy this down, highlight it, because that is the Pythagorean theorem. I'll give you a moment to pause this video and copy down this image before we do some practice. Okay, so let's take a look at some practice. Have your worksheet out in front of you and your graphing calculator ready. In the first section, 1 through 4 and 5 and 6, we're asked, do the following lengths form a right triangle? So let's take a look at number 1. The first thing we do is we label where A, B, and C are. Remember, C is the longest side. So right here, this has got to be C because it's the longest side. So we're going to put a C right there. A and B can be either of the other two sides, meaning 8 could be A or 8 could be B. It doesn't matter because those are considered the legs. So let's plug these into the Pythagorean theorem now. A squared plus B squared, and see if it equals C squared. If it does, we've got a right triangle. That's what these questions are asking us. Are each of these a right triangle? Because we don't see the right angle symbol. So we can test each of these in the Pythagorean theorem to see if they do form a right triangle. So we'll take 6 and plug it in, and 8 and plug it in, and finally 9 and plug it in. You can use your perfect squares knowledge or your graphing calculator. Don't forget that quiz is coming up Monday. And let's calculate. It's 36 plus 64. Does that equal 9 squared, which is 81? Well, that adds up to 100. And that is definitely not equal to 81. So this would not be a right triangle. Okay, so in review, for each of these first 6 problems, the largest number has got to be C in your Pythagorean theorem. So find the largest number, and that's got to go in for C. The other two remaining numbers can go in for A or B, it doesn't matter which, and then test them out. If it works, it's a right triangle, meaning if these two numbers at the end are equal, it's a right triangle. If they're not, it's not a right triangle. So why don't you pause this video and try number 2 on your own or with your group, and then we'll go through it together before we jump to another section. Go ahead and pause and try number 2. Okay, assuming you've tried number 2, in number 2, the largest side is the 13. So that has got to be C in the Pythagorean theorem. That can make this A and B. And so writing down the theorem, we've got A squared plus B squared equals C squared. So we'll plug in 5 for A, plus 12 for B, and 13 for C. It has to go in for C, 13, because it's the longest side. 5 squared is 25, 12 squared is 144, and 13 squared is a perfect square, it's 169. 25 plus 144 is 169. So these side lengths do form a right triangle. So yes, it is a right triangle. Okay, we're going to jump to another section now where we're going to apply the Pythagorean theorem to find a missing side. Let's go. All right, let's take a look at number 7. In this section, we have to find each missing length to the nearest tenth. The very first thing we do in all of these is identify where C is first. Remember, find the 90-degree angle, and C is opposite of that. So this is side C. Making these other two sides A and B, it doesn't matter which one. So I'll put an A here and a B here. Write down my theorem. A squared plus B squared equals C squared. And now we'll plug in the numbers for what we know. We've got 4 squared plus 8 squared equals C squared. Okay, how's your mental math? Do you know what 4 squared is? That's 16. That's 64 equals C squared. Let's combine those two to get 70 and then 80. 80 is not a perfect square, so now we're going to use our graphing calculators. Remember how we undo something to the second power? What's the opposite of squaring something? It's the square root. So the square root will cancel. So C is equal to the square root of 80, which we're now going to round to the nearest tenth. So grab your graphing calculator. Second x squared, 80, enter. So C is approximately 8.9. That would be our final answer for number 7. Okay. Let's take a look at number 8, just to the right. Let's do another example together before you try one on your own. In number 8, the very first thing we want to do in all these is find that right angle, and the opposite of that is the letter C. So that's got to be the hypotenuse side, making this A and B. So here we go. Let's zoom in on number 8. A squared plus B squared equals C squared. Plug in your numbers. 6 squared plus 3 squared equals C squared. So that'll give us 36 plus 9 equals C squared. 36 plus 9 is 45. Let's solve for C by square rooting to cancel those two things out. Square root. So C equals the square root of 45. All right, calculate. Press the button second, x squared to get the radicals show up. 45, enter. C is approximately 6.7. Don't forget to box your final answer. All right. So try one on your own now with your group. How about number 9? It's right there. And then we can go through it. If you don't have enough space on this worksheet, you're welcome to work in your graphing notebooks. That's totally fine. You don't need to redraw the triangle when you do that, but you do need to label A, B, and C and what they are on the worksheets. Okay, so go ahead and try number 9. Pause this video and return to this video when you're ready to go through it. Okay, how did we do? There's our solution to number 9. A squared plus B squared is C squared. So 7 squared plus 10 squared equals C squared. Squaring each one of those, and then square rooting in our last step, we get C is approximately 12.2. All right, let's go check out another section of problems where it's not the hypotenuse or the letter C that's missing. It's A or B that's missing. So we're going to go down to number 15 here. And in number 15, as we work to do this problem, we're going to first label A, B, and C. So opposite of the 90 has got to be C, the hypotenuse. We can make this A and this B. Does not matter for A or B. Those are interchangeable. Okay, here we go. A squared plus B squared equals C squared, right? Pythagorean theorem. We don't know A, but we do know B is 3.6 and C is 7.4. So notice we have a number for C this time, but it's one of the legs we don't know. So A squared plus 3.6 squared, that's 12.96 equals 54.76. All right, at this step right here, it's now time to algebraically solve for A. So we need to subtract this 12.96 from both sides. We got to clear this out of here. So 54.76 minus 12.96 is 41.8. So A squared equals 41.8. And you already know how to get rid of something to the second power. We square root. So A is going to be approximately square root of 41.8. That's 6.5. Okay, so recap 15. We labeled C across from the 90-degree angle. We also labeled A and B. We don't have A. We plugged in the numbers for B and C. We squared our numbers, and then we started to remove things away from A. We subtracted the 12.96 from both sides, and then we square rooted to get rid of the second power, and we rounded our answer to the nearest tenth. Okay, how about you take a try at number 16 over here? Pause this video and return to it when you're ready to walk through it with me. Ready to go over number 16? Okay, let's take a look. Find that 90-degree angle. Opposite of that has got to be C, the hypotenuse. We'll call this A and this B, and write down the Pythagorean theorem. Let's plug in the numbers from our picture. 3.9 squared plus B squared equals 11 squared. So using the calculator, 3.9 squared is 15.21 plus B squared equals 121. 121 is going to be subtract 15.21 from both sides. To give us 105.79. So B squared equals 105.79. Solve for B by square rooting. So we'll square root. And that'll give us B is approximately 10.3. Box your final answer. Okay, how did you do? Pretty good? Great. Okay. So as you look at the rest of this, you could have the hypotenuse. You could have a leg that you're solving for. So there's plenty of practice on here. So go back to that first section and take a look if those sides form a right triangle by labeling A, B, and C. C is the longest. Plug them in. And remember, if it works, it's a right triangle. If it's not equal, it's not a right triangle. You don't need to draw a picture for 5 and 6. They already tell you what A, B, and C are, so just plug them into the Pythagorean theorem. Again, if you don't have enough space, you're welcome to use your graphing notebook. You don't need to recopy down pictures in your graphing notebook, but you do need to label A, B, and C. Good luck, students, completing the rest of this for the remainder of the hour. The substitute will collect this before you leave class, so please work diligently and put back all of your supplies with around 3 minutes left in class. That means rulers, calculators, colored utensils that you borrowed. Please put those back before the end of class and tuck in your chairs. And please be respectful toward the substitute teacher. I will be returning in class tomorrow. See you soon. Have a great day.